In this video I would like to show you one of our phase contrast kit. This kit comes in a package in this shape and it includes a couple of items. Objective lenses such as 10x with the numerical aperture of 0.25, 20x with 0.40 numerical aperture, 40x with numerical aperture of 0.65, and 100x with the numerical aperture of 1.25, which is oil immersion. The package includes a central telescope for aligning the phase and a green filter, plus a phase contrast condenser turret. With this phase contrast, you can collect the images in the bright field mode and also phase contrast, and depending on the objective lens magnification, you select one of these positions on the turret for 10x or 20x, 40x, 100x, and also you can do dark field imaging. This condenser has 1.25 numerical aperture. We have installed the condenser and phase contrast objective lenses to one of our Upright Biological Microscopes, which is BUM800. We are going to collect a couple of sample images using a USB3 CMOS cameras, which is a 2.3 megapixel and 1/1.8 inches sensor, and we have connected the camera using a 0.5x CMOS adapter. So over here we have a thin section of an onion skin, and we are going to look at this sample at different magnifications. Let's start with the bright field using 10x objective lens. So I'm going to switch to a phase contrast from the condenser, and next is we switched objective lens to 20x. Now I'd like to come back for comparison to see. First we see the image in phase contrast, and I come back to bright field. You can see the image differences using this condenser. Next we switch to 40x. You see it first at bright field mode, and I'm going to use the 40x from the condenser, and we may need to retune the focus just slightly, and depending on which part of the sample we are interested, we can adjust the focus. Next is using 100x, but obviously this will not be in a good quality because the objective lens is oil immersion, and this will be the phase contrast. And I switch to bright field to give you an idea that what happened using this objective lens. As a bonus point, I'm going to show you another objective lens we can add to this kit, which is a 60x, and we use this 60x objective lens for dark field imaging. So first we look at the bright field to see how the image quality is, and again the focus will be really matter. And from the condenser we can choose either 40x, so the image will be this quality, or we can select 100x since there is no 60x in the condenser. In this video we are going to look at a sample which is Tilia or basswood using different objective lenses. At this moment we are seeing the image using a 10x objective lens in bright field mode. So let's switch to 10x phase contrast from the condenser, and here you can see the image difference. We can retune the focus. Next I'm going to switch to 20x objective lens, and we can align the focus, and I come back to bright field. You can see the difference between these two, and next we switch to 40x objective lens, and the image we see here, it is in bright field mode. And from the condenser we switch to 40x, and you can see the difference. Now we switch to 100x, so I like to start from bright field. Obviously the image will not be in a good sharp focus because the objective lens is supposed to be used with oil, and in this short demonstration I'm not going to add oil. So we look at this in phase contrast, and the image is not that bad, you can see. And as a bonus, I'm going to show you another objective lens we can add to this package, which is a 60x objective lens. And for this one I start with the bright field, just to show you an idea of the image quality basically. So this will be the bright field image, and for 60x we can either use 40x from the condenser or try 100x. So it depends on your interest and the type of sample. This can be matter. You may also need to retune the condenser location from the microscope. And one more thing is basically, if you look at this phase contrast lens from the back, you'll see a phase ring inside this objective lens. Please do not use phase contrast lenses for epifluorescence imaging. The UV light will damage the phase ring inside the lens and it will melt. Thank you.